So I'm Nancy Pitts. I'm a professor at Dalhousie, which is the agricultural campus of Dalhousie University. Located here on our campus is the Faculty of Agriculture, and I teach many courses, but the one I'm going to talk to you about today is my experience teaching first year chemistry, so Gen Chem 1 and Gen Chem 2. So one of the things that I do in my first year Gen Chem classroom is I use a lot of analogies. One of the analogies I'm going to share with you are these two loonies. They may look like loonies to you, but in the scenario that I create with my students, I talk about them being electrons. And in fact, I get a student to volunteer and do a little role play with me. And I create kind of a little story around it. I tell them, let's go to Tim Hortons. I'll buy the hot chocolate and we will share it, of course, in a hygienic way with 2 cups and so on. And then I make sure that the whole classroom of students understands that these are the 2 electrons, that I'm the atom that brought both electrons, and yet we're sharing in the end. And then because I like the element of surprise, I thank them, and the next day I come back into class. In my pocket I'll have a Tim's card worth $5, and it's not so much what it's worth, but it's the element of surprise that sometimes students that volunteer in my class get a little extra reward. One of the other things that I do in my class about mid-October of Gen Chem 1 is I walk in with parts of my little teaching elephant and I pass them around to the students for 2 purposes. I want them to understand that scientists make observations. And so we go through all of the pieces of my poor little elephant, and then I walk around the classroom and actually show them how they fit together on the elephant. So here is the weak acid and weak base section of our course. How does it fit and combine? How do you understand it in the context of the rest of our chemistry course? The section on nomenclature was not just something to live through and get past, but we're always going to use it. So we use a lot of analogies and a lot of, shall I say, learning and teaching tools in my classroom. So in my first year chemistry course, I want my students to start to use some of their higher thinking orders. And my term tests are done in the class. It's a scheduled 50-minute slot. There's not a lot of time there for them to think, to do analysis, to do evaluation, to do some critical thinking. And so in a test environment here at the Faculty of Agriculture, my tests for first year chemistry are 50 minutes long because of timetabling and scheduling. It doesn't really give the students much time to really think using those higher order thinking skills. So one of the things that I've come up with over the years is what I call questions to think about. So in fact, I use the acronym QT²A, and students very quickly learn that they should review the last sections before they go into a test to see what are the QT²As that they should be thinking about and prepared to give me a well thought out answer for. Another way that I try and encourage them is usually on Monday morning. I take about 5 minutes and we have the cow session. A pun on the fact that I'm here at the Faculty of Agriculture, and so on Monday mornings we spend about 5 minutes doing the cow session. And so it's not really talking about my little stuffed cow. It's talking about a chemistry of the week topic that has nothing particular to do with the topic of the whole content of the syllabus at that point. And we look at something that's current in the news, that's currently on some of the science sites perhaps, and we look at it not just from the chemistry perspective, perhaps we're talking about the biology perspective. Sometimes I'll even ask them, so what are the social implications of this new innovation or this new product? What are the environmental impacts? And so trying to get them to do some breadth to their thinking as scientists.